Let's do a similar example. Here the question asks, what the question asks is to what is the representation of this parametric equations. Now this is almost the same as it was in the previous case, but the only difference is here x is given as sin 2t, but in the previous case x was given with respect to cosine t. So now, but the calculation that comes thereafter will be the same. You just square both variables and add them up. So because of this trigonometric identity, you will lead to this relationship between x and y, and this is the equation of a circle, and this one represents the circle, I mean the radius. So the usual equation of a circle centered at the origin is of this nature, where r represents the radius. And also there is another difference, right? That is, now to get the initial point, we need to substitute this starting value of t. So accordingly, the starting coordinate of x will be 0 and y will be 1. So that means we are going to start our curve at this point, and then we and you can see that when the value of t increases, both x and y will change towards the positive quadrant. It's like where t starts from 0, and when it starts to increase, both these values will first give its x and y coordinates in the first quadrant. This is the first quadrant because both x and y are positive. So it will start forming the points within this circle. Now, as we already know this equation, we know for sure that both x and y should satisfy this relationship. That means it must be within the circumference of this circle. But the thing is, depending on the value of t, it will generate the suitable points. But anyway, it will lie within this, on this circumference. And then let's say, how about now? See here, t runs from 0 to 2 pi. Okay, so how about a value like 0 t equals pi by 2? Then x will be equal to sine 2 times pi by 2, y will be equal to cosine 2 times pi by 2. So this will get cancels out, and then you can see that this is equal to 0 and y is equal to 1, negative 1, right? So at pi by 2, this will reach this point. Okay, so this will be 0, negative 1, right? That is for pi by 2, right? So it starts at t equals 0, and this is for t equals pi by 2. So, and we remember we should mention the direction of the curve according to the increasing order of t, right? And likewise, let's have a look at the value of x and y when it is 3 pi by 2. Then x will be equal to sine 2 times 3 pi by 2, which is equal to negative 1, and because these two will get cancels out. And then sorry, this is not negative 1, this should be 0 because this is sine 3 pi, and y will be equal to 3 pi over 2 times 2, because you have, like originally you should have y equals cos2t, and don't forget this 2 in front. Okay, and this will be equal to 1, I mean negative 1. So now see here we once again have the same coordinate. See, x equals 0, x equals negative 1. So it's a bit strange, right? So even for 3 pi by 2, we didn't even complete the full, like we didn't even reach the final destination, or I mean the terminal point, but here we are repeating a certain value. So what is going on inside? So what actually happens is this circle will complete a full cycle when t runs from 0 to pi, and 3 pi by 2 is greater than pi, right? So now see, when t is equal to pi, x is equal to sin 2 times pi, and y is equal to cosine 2 times pi, and that is equal to 1 and 0, right? See, starting from here, when t is equal to 0, it goes like this, and when t is equal to pi, it will complete the full circle. So for the remaining values, it starts going on the same path one more time. So at the end of t equals 2 pi, this curve has completed 2 rounds across the same path. So that's some sort of a nice property which you can find when you express the curves in a parametric format.